Okay, I'm Jim Frankenfield, and this is another one of my short problem solution videos. Um, this one involves trig problems that are best solved using a unit circle. And I'm just going to solve a problem that came up on Help Group. The same one was posted a few places. I have or will have shortly another video that explains this unit circle approach a little bit more. And it'll be a little more instructional as opposed to simply solving the problem. So let's look at the problem that we need to solve. And the problem that was, as it was posted, is we need to find a value x for an angle such that the sine of x is the same as the cosine of another angle. We need to find the sine of x that's the same as sine of 8 pi over 23. And we need to find a cotangent of x, an x such that the cotangent is equal to the tangent of pi over 8. This is take 2. Take 1, I tried to do all three of these on a unit circle, and it got a little crowded. And also these numbers aren't hard to work with if you're doing this kind of trig problem. But I'm going to make the numbers easier and also the diagram a little less cluttered by using the same angle. So I'm going to just use pi over 8 for all of these. And actually the first one is to find an angle x that has the same sine as pi over 8. So here's my unit circle. And on the unit circle we read the cosine on the x-axis and we read the sine on the y-axis. And it's a unit circle, so if I take the cosine, let's take pi over 8. Let's just look at the sine first. The sine is going to be on this side here. So here's my sine value, and if I go over here, I have a point over here, which is the same sine value. So I'm working in radians. The problem was given in radians. That's why we have pi over 2 for 90 degrees, we have pi for 180 degrees, and we have 3 pi over 2 for 270 degrees. So I went up by pi over 8. That means I can come up here pi over 8. You can see this from the symmetry. And pi minus pi over 8 is 7 pi over 8. So this point is 7 pi over 8. And that's the answer to our first one. Sine of 7 pi over 8 is the same as sine of pi over 8. I could also take pi over 2, which is 4 pi over 8. And I could come down here 3 pi over 8. So this is plus 3 pi over 8. Either way, I'm going to get 7 pi over 8. There are a couple points down here that will have the same magnitude of sine, but those will be a negative sign. So we have to be careful of our signs in the quadrant we're in. So this first one, and this one I can't relate to an identity. You can use your sum of angle identities, but it doesn't follow very directly from the unit circle. So the next one is to find top one is the next one, sine x such that cosine of pi over 8 is the same thing. So cosine of pi over 8 is down here. And here's my cosine. I want to have a value where the sine is the same as that. So that is, let's see if I can measure it more or less, 5.5. So up here is going to be where I want the sine. I want this distance that was the cosine to now be the sine. And I can go across here, and I'm going to have two choices this time. Last time one of the values was given to us and the other one was, there's only one other choice. This time I'm going to have a possibility here and a possibility here. So instead of going up pi over 8, I'm going to come down pi over 8, and this is going to be pi over 2 minus pi over 8, which is 3 pi over 8. Or I could come up 3 pi over 8. Over here I have pi over 2 plus pi over 8, so this is 5 pi over 8. So I have two possibilities on the second one. So yeah, there's an identity. Sine of pi over 2 is equal to minus some angle theta is equal to cosine of theta. And you can find this in trig identity tables, and you can see here how that identity is coming into play graphically. So here's cosine theta, and sine of pi over 2 minus theta is the same thing. And there's a similar one for interchanging sine and cosine. So the point that was sine here is now cosine over here. So that's the second one. And we had two choices for that one. The final one is that tangent of pi over 8, cotangent, we need to find it so that cotangent is equal to tangent of pi over 8. So tangent of pi over 8 is sine over cosine. So it's this value, this last one in red, it's this value divided by this value. Cotangent is cosine over sine. So I want this one divided by this one. This will be sine and this will be cosine, which happens up here at this point. So I get 3 pi over 8 again. Yeah, 3 pi over 8. And I'm also going to have a second choice this time. I can't go over here because over here my cosine's negative and I'll have a negative cotangent. And I can't come over here because we have a positive cosine and a negative sine. But if I go straight across, over here, okay, this is the same value of cotangent, and cosine and sine are both negative, so when you divide them you get a positive cotangent. So this point works too, and what I did is I went halfway around the circle, which is pi radians. So this is 3 pi over 8 plus pi, which is 11 over 8 pi. 12 over 8 pi would be here at the bottom. So that's how you can do these kinds of problems. This is just one example. I'll talk a little bit more in another video that I'll create soon and put a link in the description for it. I'll talk a little bit more about this unit circle approach. It makes these problems really pretty simple. Maybe you need a little bit of practice at it, but it doesn't take a lot of practice and use to be able to answer these questions pretty quickly. So that's it. I hope that helps, and watch the other video that's either there or will be there shortly. And I'll see you then. Bye.